Hi everybody. Today we're going to look at some complex ion calculations. So what I'm going to do is I'm going to work through the problem on the left hand side and then fill in the sheet on the right hand side as we go. So what I have here is 300 mils of a 0.1 molar potassium iodide solution, and it's reacted with 200 mils of a 0.25 molar lead 2 nitrate solution. And I want to know what the final ion concentrations after everything mixes. So the first thing we need to do is we need to write out a balanced equation. And here we need to use our solubility chart to figure out that the lead 2 iodide is the one that comes out as a solid. That means on the right hand side here, our potassium and our nitrate are going to be spectators. Okay, so now since we know that the lead 2 iodide is going to be the precipitate, comes out as a solid, we can use that as our net ionic. So next step, and that's what I've done here with the ions on this side. If we look, all the ions here are the ones that we see over there. I have a little star beside the nitrate because there's going to be the original amount, there's 2 of them, and this is the moles before the reaction starts, but we'll get there in a second. So to figure out the moles of before, all I'm going to use is my simple molarity calculation to go moles times, or molarity times volume to equal moles. So for the potassium iodide, 0.1 times 0.3 equals 0.030. So in this row here, I have 0.0300, and I have the exact same thing for the iodine because it's a 1-to-1 ratio. For the lead, I'm going to do the exact same process but use its value, so 0.25 times 0.2. For the lead, that gives me 0.5, or 0.05. Let's put a 0 in front. And for the nitrate, this is going to give me 1 molar because there's twice the amount. There's 2 nitrate ions when it breaks up. So now what we need to do is we need to look at what's what. So here I know that this ion here for the potassium is going to be the spectator. It's going to be one of the spectators. And so its concentration is going to remain the same. And the other spectator ion is going to be the nitrate. So this is a spectator as well. Spectator. And so its concentration is going to remain the same as well. So what I have to figure out now is between these two, which one is going to get used up first, because I'm going to have a limiting reagent there. So next I need to find the moles after, which is I did for my spectators, but now I have to find for my limiting reagent. So I'm going to use my little fake mole ratio here, and when I do that and I multiply, I figure out the lead side is much larger than the iodine side, so the iodine is going to be my limiting reagent. So this is going to be my LR, which means that it's going to have 0. It's gone. It's out of the everything's been pulled out as a precipitate. There's no iodine left. For my lead, I have to use that initial, my original amount of my limiting reagent, which was 0.3, times by my ratio to get rid of the iodines to figure out how much lead was used up. When I figure out how much lead was used up, I'm going to subtract that from my original amount and figure out that I have 0. So let's put this is the excess, and I have 0.0350 molar left. My total volume is going to be the same as just the 0.3 mils, or 0.3 liters times 0.2 liters. So 0.500, and we're just going to, it's going to be the same for each one. And my final ion concentration, what I'm going to do is I'm going to take what my moles after, so it's always moles after, divided by my total volume. So in this case, I'm going to take 0.03 divided by 0.5, so I'm going to 0.0600 molar. And then I'm going to take 0 divided by anything, that's 0. And here, oops, this shouldn't be. So I have 0.35. Now I got 0.0700 molar. And finally this one, which will be 0.200 molar. And that is how you do these ion calculations. I hope you have a good day.